Okay, so this is from that monohybrid cross worksheet you guys had from homework the other night, or the other day, I should say. And I put up the answer key, but this problem, the last one, number 4, gave people a lot of trouble. I would say more than half of the people got this one wrong. And I think a big part of that was the wording of the question. I think it was worded poorly, so it's probably very confusing as to what it was asking. But I want to make sure everybody understands the right answer and why it's the right answer. So just follow along with me, check your answer, and make sure you understand why you got it wrong if you got it wrong. And make sure if you got it right for real and you didn't just guess it right. So this is a monohybrid complete dominance problem. So complete dominance means one allele is dominant to the other. So there's only going to be 2 options for phenotypes. It says a brown-eyed man whose mother was blue-eyed married a brown-eyed woman whose father had blue eyes. Assume brown to be dominant over blue. So we know that big B is brown, so this would give you a brown brown phenotype. We know that big B little b would also give you brown because big B is dominant to little b. The only way to get blue is to be little b little b. So how do we know what the genotypes of the brown-eyed man and brown-eyed woman are? Now this is what was different on your worksheet. I just said mother and father, and that's probably what confused everybody. So what's the genotype of the brown-eyed man? Well, the brown-eyed man has a mother with blue eyes. So if he has a mother with blue eyes, the mother has to be little b little b. So that means that the father can only be big B little b. So we know that the man is big B little b. Because if the mother had blue eyes, she could only donate a little b. So this could not happen in that scenario. The mother, the woman in the scenario, also has a blue-eyed father. So that means the father's blue-eyed, so the mother also has to have a heterozygous genotype. Because the mother also has a father with blue eyes, so the father could only donate a little b. So now we know the genotype of the brown-eyed man, and we know the genotype of the brown-eyed woman. So let's fill in our Punnett square. One parent goes on one side, the other parent goes on the other side, and again, it doesn't matter where you put it. Well, they're the same in this case, but it doesn't matter where you put them as long as you have the alleles together. And now we're going to fill in our Punnett square. So this box is going to be big B from these two. This box is going to be little b, big B, right? Big B, little b here. This box is going to be big B, little b, and this box is going to be little b, little b. So that's our Punnett square. So a lot of people had this part wrong, and again, I think it's because of the confusion of the wording of the problem. Now finally, I did see some people that got to this point and then they filled in this part wrong. So once you have this done, this should be relatively easy. So what's the genotypic ratio? Well, remember, genotype, we're looking at the letters here. So it's going to be homozygous dominant to heterozygous to homozygous recessive. So how many homozygous dominant do we have? Well, we have 1. So we're going to put a 1 there. How many heterozygous do we have? We have 1, 2. So we're going to put a 2 there. And how many are going to be homozygous recessive? We only have this 1, so we're going to put a 1 there. So it's a 1 to 2 to 1 ratio. Now for the phenotypic ratio, I want to know brown to blue. So I have 1, 2, 3. All 3 of these are going to be brown because remember, big B is dominant to little b. So it's going to be a 3. And how many are going to be little b, little b? How many are going to be blue? It's going to be 1. So a 3 to 1 ratio. So what's the probability that the couple will have a blue-eyed child? 25% chance. So that's the correct answer. And this problem was a little more challenging because you had to figure out the genotypes of the 2 individuals that are having the baby by looking at their parents. So I didn't tell you they were heterozygous. You had to figure that out by looking at the parents. So if I didn't tell you that, you wouldn't have been able to get this right. Please let me know if you have any questions.